Okay, we now turn our attention to the while loop. The while loop is the second looping structure that we look at in Python. So this is the syntax for the while loop. We start with the keyword while. There's a condition to check, and then there's a block of code. It turns out that a while loop will execute the block of code as long as the condition is true. The while loop, it's really important that we have like a starting condition. And then it's really important that within the block of code we have some statement that will allow us to somehow get to a situation where the starting condition becomes false. And we can see the value in this because if we don't have that situation, then we will stay in the while loop forever. And that's not a good situation to be in. So let us demonstrate the while loop. Suppose I want to print the numbers from, say, 1 to 10. It's a good idea to have a starting condition. And here I'm just saying number is assigned to 1. And then I'm starting the while loop, so I start with the keyword while. And the condition I'm going to check here is that number here is less than 11 because I want to go all the way up to 10. And as long as number is less than 11, then we want to print number. Okay? So, as we can see here, number is definitely less than 11. We want to print number. And this is the statement that follows really important. Here, I'm going to say number is assigned to number plus 1. And this statement, what it's doing, it's giving us an opportunity to get closer and closer to the end condition. And the end condition here is when number is no longer less than 11. Then we can see, okay, it's time to break out of the while loop. This is really important. The idea of having some statement within the body of the while loop that terminate the condition, that makes the condition false. So let us run this program and see what we will get. Okay, so we run the program and we can see that we have the numbers from 1 to 10 printed. So first time through, number is assigned to 1, 1 is less than 11, it will print number, then number will be incremented to 2 because number is assigned to 1 plus 1, which is 2. The condition is still true, number is 2, will print 2, then increment number to 3. The condition is still true, will print number which is 3, and then so forth and so on until number is no longer less than 11, then we'll break out of the while loop. So a very important structure there, and this is the second looping structure that we look at, and in particular it is the while loop. Suppose we want to use the while loop to print the square numbers, something similar to what we did with the for loop. So here, I'm just going to comment the first while loop statement that we have because I want to write a new structure. So again, I'm saying while number is less than 11, and here we want to print, and here we're going to say, just like what we did in the for loop, number squared is, and again the square for number is number times number, and again we need to have some statement within the body of the while loop that will bring us closer and closer to making the condition false. Let's see what we're getting here. So here 1 squared is 1, 2 squared is 4, 3 squared is 9, as expected. Okay? And now for the challenge. Suppose we want to write a Python program that asks a user to enter a number to square up to. Then I want you to define a function called squared up to that takes an integer, which is the number entered, and then I want you to use the while loop this time to print the squared numbers from 0 up to the given number. We don't need this hint anymore. We know already that a number squared is just a number times a number. So I want you to have a go at that one. Good luck. Okay, now we look at the solution. So again, I want to define a program, ask the user to enter a number squared up to. And I want to define a function. So let's go ahead and define that function first. So the function we want to define is called squared up to. This function should take one value, which is a number, and then we take that number there, and then we want to basically square it up to that number, but want to use a while loop for that. So it's a good idea here to have a starting condition, and let us say we have an index here, and this index where we're just starting the index at 1. Okay, so when I say index is assigned to 1, and then basically want to say while our index is less than the number, so the number that we want to square it up to. So while that condition is true, then basically we want to print the squared of that number. So basically we want to say here that index squared is, and again here it's going to be index times index. And again, what we must have in the while loop, the body of the while loop, we must have a condition that will eventually allow the condition, we must have a statement that will eventually allow the condition to become false. And here, the statement that we're going to have is index is assigned to index plus 1. So as we iterate, as we go up on index, as we increase the value of index, then eventually index will no longer be less than number, and that will make the condition false. So that should do it for our function. We define a function called squared up to. It takes a number, and then it will print the squared up to that number. And now we're going to ask the user to enter the number to square it up to. So here we're saying number is equal to, and at this stage you should remember that we have to use the int function there to just change the input that we're taking into an integer. So here I'm going to say enter the number to square up to. Take that number here, and then once we get that number, once we get that value, we turn it into an integer. We're going to just want to call the function. So this function here is squared up to, and to squared up to, we're going to send the value of number. So let us evaluate this and see what will happen. So enter the number to square up to. This time I'm going to go up to 13. And as we can see there, again, 1 squared is 1, 2 squared is 4. But again, we have a problem here. We wanted to go up to 13, but it turns out that here we're only going up to 12. How can we solve this problem? So here we look at it and we realize that, okay, we're going all the way up to number, which is what we're entering here. So the condition is becoming false here. So it's less than number, as long as it's less than number. So when the condition gets to equal to number, the condition will be false, and therefore we will not go back into the while loop. So one way of solving this problem here, we can either send number plus 1 to the function. So instead of sending, allowing it to be false there, then we can say, okay, we're going to go through another iteration. So let us try this and see if we'll get the desired solution. So we want to go up to 13 again, and then you can see that that is one way of solving the problem. Now a question for you, can you think of another way in which we could solve the problem? Instead of putting a number plus 1 here, can you think of another way in which we could solve the problem? Think about it. Okay, I'm going to introduce you to a very powerful statement in Python, and it's called the break statement. There are rare occasions on which we want to come out of a while loop even though our condition is true. Very rare occasion, but very powerful concept to learn, and you have to focus on this one to get it. Okay, I'm going to explain, let me just explain the syntax first. So we follow the general syntax while the condition is there, and then the body of the loop code will execute. But here we're introducing something new. We're saying if, and we have a break test, and if this break test is true, then we want to break out of the loop, and this is breaking out of the while loop. If this is not true, then we continue with the code within the while loop. And that is why it's really important that you understood the if statement that was covered earlier. Let me use an example to illustrate this one. I'm going to introduce a new concept here to you, and this will come up in the next chapter, the whole idea of lists. So basically, we have just a collection there, and it doesn't matter what order we have the numbers in, that is irrelevant now. So here we have a list of numbers, and I just add one more to our list. Okay, so we have a list of number called Z. And now I'm going to use a while loop just to go through this list. In fact, I'm not just going to use a while loop. I'm going to put it within a function here, and I'm going to call this function find7. So let us say we're looking for the number 7, and we're hoping that number 7 appears somewhere in this list. So we define the function called find7, and I'm just going to say a value here. In fact, find7 here is just going to take, say, P, and that P there should represent a list. So basically, I'm going to send a list to this function, and this function should look through the list, and it should tell me at what position we have number 7 in the list. So in my function, I'm going to initialize a variable called I, and clearly I'm initializing it to 0. Then I start with my while loop, and in my while loop, the condition is that while y is not equal to the length of p. So here it's testing the length of p. In this situation, the length of p is 1, 2, 3, 4, 5, 6, 7, 8, 9, because there are 9 elements in this list. Now, I'm just going to print the values that appear in this list. So let us say I just say print here, and here to get the value in the list, I'm going to index the list. So I want to print the value in the list there. And again, very important in the while loop, I have to use a counter. I have to use some statement that will eventually make the statement false in the list. Okay, so that will make the condition false there. Okay. This is a modular design. We're going to take it step by step, and I'm going to show you how I'm going to bring in the break statement here. So let us just test it at the moment. And here I'm going to say print find 7, which clearly it's not doing that now. It's not finding 7, but this should just print the list as it appears there. So let's just try that and see. Okay, yeah, we have to save the source code there, and we can see that the list is printed first with 2, then 4, then 6, and so forth. And you should be able to see that that statement there will print the list as we want it there. Now I'm going to introduce the break statement there. And now within the while loop, I am going to test something, and this is where I'm bringing in the if break test and the break section here. So basically, I'm saying that if the element here that I'm looking at position I, if that element is equal to 7, then, okay, very important, and we need a colon there. But if that element is equal to 7, I want to break out of the loop. So I'm going to break. But before I break, I want to send a message to the screen. I want to print on the screen. Just want to say breaking out of loop. Say breaking out of the while loop. Just so that my user can know that I'm breaking out of the while loop there. And in fact, I want to send some more information to the screen. I want to tell the user exactly where I'm breaking out. And I'm breaking out while I found the value. So I'm going to say found at position. And the position that I found 7 would be at position I. And then I'll break out of the loop. So I break out of the loop there. And in particular, after breaking out of the loop, I no longer want to print the list. So I'm no longer printing the list there. And if we match this to the syntax, I've done the if break. I've done some code here that if I don't go in the if statement, then I'll increment the value of I, and that is really important there. And just to show you that I'm actually outside of the while loop, I'm going to print a statement there. And this statement will only be printed after I've exited the while loop. So I'm saying here after the while loop. So after the while loop, I'll print that statement. Let us try this and see. Okay. So here we can see breaking out of the while loop, found at position 4, and then after the while loop. Now let us check to see if 7 was actually at position 4. So that's position 0, 1, 2, 3, 4, which is value 7. This is quite powerful here. We've introduced some new things that will be covered in our next chapter here. And I'm just going to signpost them. So this is a list. Very powerful data structure that is used in Python. We've used the length function to take the length of the list there. And the main focus was the break statement. Have a look at the break statement here. Go and try the challenging questions that follows. And I'll add another question to see if you really understand the break statement. Good luck.